Welcome back to another Algebra 2 lesson. We're still on section 2.5, looking at solving systems of equations. Today we're going to be discussing the difference between solving using substitution and elimination, just kind of learning when to use both methods. If you look at this first system over here on the left, one thing you should notice is that we have a variable by itself. Remember, if you think back to the previous two videos, when you have a variable by itself, you want to use the substitution method. When you have a variable by itself, this method is already set up for you, right? If you know what something's equal to, that means you're allowed to replace it. So if I have what x is equal to, which is y minus 3, I can replace x in the other equation. Let's see what that looks like for this example. Taking our equation, 3 times x, get rid of the x and replace it. Everything else in the equation is still coming along, and we have something like this. From there, we know this process, we know how to solve, go through your distribution, make sure you're combining your like terms, and you're isolating your variable. Okay, we've talked a lot about that solving process. Distributing, we're making sure we multiply. Combining like terms, use the signs that they have. And then once you start to move stuff, you're using the opposite, the inverse operations to get those variables by themselves. First thing we end up finding is y is equal to 4. Well, remember, once you have one variable, what you can do is you can always plug back in. So if we still need to find x, I can take that x equals y minus 3 equation. But since I know what y is equal to, I can replace that y to now find the x value. Now that we have both values, that is a coordinate we could represent as x comma y. Let's look at another example. So substitution, again, you want a variable by itself. Remember, another word you might use besides by itself, you might use the word isolated. Well, when I look at this second example then, the second problem, there is no variable by itself. X and y are both on the same side, and they both also have numbers in front of them. If you tried to use substitution here, what generally happens is you're going to deal with a lot of ugly numbers, whether they're fractions or whether they're really weird decimals. Whenever you see something like this, you want to avoid substitution. Instead, we want to use our elimination strategy. Remember, for elimination, what we're looking for is opposite terms. When I look at this problem, I don't have opposite terms yet, and that's okay, because we're always allowed to create opposites. If you don't remember how creating opposites work, what we're allowed to do is we're allowed to multiply our equations. So if I take one of these equations, I'm just going to rewrite them here. One thing I'm looking for is, okay, what value can I multiply into another? For example, if I look at 3 and 5, well, 3 and 5 don't multiply into each other, so they're going to be a little bit more complicated to create opposite terms. You'd have to multiply both equations to eliminate the x. But when I look at the y's, I have negative 2y and 4y. I do know that I could multiply this top value by 2, and that would give me a value of negative 4. Remember, opposite terms are the same number just with different signs. So if I were to take this 2 and multiply it, I'd get 6x minus 4y. That's exactly what I want, because this other equation, the bottom equation, had positive 4y. Negative 4 and positive 4, those are both opposite terms. Remember, one spot a lot of people make mistakes when they're multiplying here is they forget to distribute this 2 to both sides of the equal sign. They forget to take the 2 and multiply it with the 8 in this case. If we do so, though, that would give us 16. So once you have your opposite terms, again, if you need to multiply, go through that process. Sometimes you have to multiply both equations to create opposites. But once you do that, elimination's pretty nice because you can just add your equations. The opposites go away. They cancel out. So what I'm left with then is 6x plus 5x. Combine that. And again, add your other like terms on the other side of the equal sign. And it looks like you get a value of negative 22 there. Solve for your variable. That's just one step to get x by itself. And you end up getting your first value of negative 2. Well, once you have one value, just like the problem before, plug back into one of your equations. It doesn't matter which one you plug into. I would use one of the two original equations, but use whichever one you think looks easier. Personally, I like the top equation because the values are a little bit smaller. When you have that equation, just make sure you're replacing the variable that you know with the value you just found, and then you can start to solve. 3 times negative 2, we can multiply, and then start to use our inverse or our opposite operations to move everything to the other side. Divide by negative 2, and we end up finding y equals negative 7. So our solution then is negative 2, negative 7. That is our x and y coordinate for this problem. So here you can kind of see the difference between both methods. You've got substitution on the left, elimination on the right. Again, substitution, you need a variable by itself. That way you can plug it in. And then elimination, you need those opposite terms. Same number and variable, but different signs. That way when you add them, they cancel out. Let's look at one other example over here. When I look at this one, I don't have opposite terms. I don't have a variable by itself. So I could use either method here. What I do notice is this y variable in the middle here. This y variable, I could isolate it, right? I could move the 2x to the other side. So for example, if I wanted to use substitution, I might start the problem like this. I could move the 2x away and get y by itself. 16 minus 2x. That would then allow us to use our substitution process. I could take what y is equal to, plug it into one of those variables, and we'd end up getting 3x minus 5, replace the y, and then we would proceed with our substitution process. That's one option you might take on this problem. The other process, though, you might use elimination. If you have a variable by itself, that means there's a 1 in front of it, right? There was no coefficient, so there's just a 1. And the nice thing about that is it's pretty easy to create opposite terms then if I were to use elimination instead. In order to create the opposite terms here, since y has a coefficient of 1, I could just multiply by whatever number I need in front of that variable, right? 1 times anything is just that other value. Well, if I have negative 5y, I know the opposite of that is positive 5, so I could just distribute and multiply that by 5. In doing so, you'd get this equation over here on the right. Bring over your other equation as well. And now you have your opposite terms that would cancel, and you could solve this equation. Both of these problems do work, right? Both of these processes, substitution or elimination, it does not matter which one you end up using. Again, big mistake you see I made it here. Make sure when you distribute that value, it goes to both sides of your equation. 5 would have to multiply with the 16. When you do so, I believe that gives you 80 off the top of my head. So then you would be able to end up solving this from here. There is a preview of substitution and elimination, which one to use. Again, an example like this, either one works well. Just choose whichever one you prefer. But looking at two equations here, if they're already set up for one of them, substitution or elimination, generally stick with what it's already set up as. That is the end of 2.5, solving systems of equations algebraically.